Hello, my name is Nathan Stoltenberg, and I was the team lead for this Capstone project. My teammates were Joe Fletcher, Jacob Svoboda, Nick Cooke, Elmusraty, and Logan Peticolas. And our team sponsor was Dora Raymaker, who is a research associate professor at PSU's Regional Research Institute for Human Services, and also a co-director of the AASPIRE organization. Our sponsor, AASPIRE, is a non-profit organization that brings together the academic community and the autistic community to conduct research projects relevant to the needs of adults on the autism spectrum. AASPIRE is an acronym that stands for Academic Autistic Spectrum Partnership in Research and Education. One of the many services that AASPIRE provides is a survey-based tool, also known as the AASPIRE Healthcare Accommodation Toolkit, or the AHAT survey, that helps create an individualized report for healthcare providers. After completing the survey, this tool then generates a report for the individual. This report includes suggestions for healthcare providers to help give the user a better healthcare experience. Our capstone involved taking the AHAT tool and upgrading it from its 2010 architecture. We accomplished this by upgrading it and making it more user-friendly to both users and administrators. This was done by developing a mobile application which presents the user with the original AHAT survey and the generated report, while also adding support for the administrators through a web interface. Let's take a look at that application. Upon entering the survey, the user is greeted with a list of chapters, where each chapter represents a possible situation where the user might need assistance communicating with their healthcare provider. The introduction chapter helps guide the user through the survey and explain what the survey is about. After previewing the introduction, the user can then continue with the survey. Inside each following chapter is a series of questions designed by the AASPIRE team with the help of international research facilities to help the user clarify how healthcare providers can assist them during their visit. Here's an example of one of those questions. The question is, how would you describe your ability to read? With the answers being, I cannot read, I can read some words and short sentences, etc. After answering the questions relevant to the user, they will then navigate to the report generation section, which will generate a report based on the answers provided by the user. Once generated, the report can be shared via email or downloaded as a PDF to the user's local device. To save time, I have already downloaded the report. The report consists of two main parts. The first part is the cover page, which contains information about what the report contains and how medical professionals can use this report to provide better service for the user. The second part is the following sections, which were generated dynamically based on the answers selected before. There are different sections that are generated based on which answers the user picked. For example, since I said earlier in the survey that I need my healthcare provider to use simpler words and short sentences, the report generated a statement informing my healthcare provider. Another important feature brought up by the sponsor is the ability to enter custom pronouns. As seen before in the survey, my pronouns were used to inform my healthcare provider. Example was, he will need short sentences and simple words. In the original AHAT survey, AASPIRE reached out to the community and found out that users wanted the ability to enter custom pronouns to be used in the report. We've added that functionality in both the registration page and the settings page as seen here. And that concludes the demo.
Thank you, Nathan. The target audience for our application comes in three parts. Now, the first part is the autistic community and their supporters who will be interacting with the survey that you just saw. The second part are AASPIRE admins and researchers who are responsible for generating the contents of the report and taking care of it and updating it as they learn more. The third part of our target audience are the healthcare providers who are going to be receiving the report generated by the survey. Next, we will go to Kai for some main features.
Thank you, Nick. So in today's presentation, we will be going over the features of the app, starting with the main feature, which is the admin website. which allows to the administrators and the health providers to easily interact with the data and add slide questions easily without touching the code. Also, we'll be talking about the report generation feature, which is a script-based answers that is used to generate a PDF on a mobile device. And the user can then view, save, and share those easily. We will also be talking about the app interface, which is a survey made throughout the app, which will contain instructions about the survey and multiple question types. And Nathan will take it from there.
The admin website is a unique feature because it is not used by the main user group of this application. Instead, the admin page is targeted towards the researchers and RAs for the AASPIRE organization. With the old system, if a researcher wanted to add or edit a piece of the survey, they would need to know SQL and PHP just to change something simple. This interface gives people the ability to make changes to the survey without having to know any technical information. This site is also a hub where researchers can see the answers for individual users for research purposes. If a researcher wishes to export the data for a given survey group, the admin site also offers the functionality to export this data as a CSV file. Next, Nick is going to talk about the survey itself.
Thanks, Nathan. So I want to emphasize the research that went into building the ASPIRE's original survey and its contents and design. So that survey has been up and getting feedback from users for years, and ASPIRE has been implementing feedback. So our survey seeks to take as much of that knowledge as possible and translate it into an Android application form. So that means all the text, icons, fonts, colors are from that original AHAT. Now, the main changes we made when translating it for Android was that we focused down on having small, simple, and focused pages. That means when we look at the chapters or when we look at getting a specific answer, like there's really only one job for that. Now, here's a quick, more detailed explanation on how we implemented this. So once the user logs in, the chapters are loaded and users' answers, if the user has previously taken the survey, are loaded as well. When the user enters a chapter, it dynamically loads the slide from the server and checks for the answer to see if it has been made. So if the user makes an answer, it loads it. And this gives us a very persistent answer for the users. That way, they can go back and forth between slides and see the same stuff that they would expect to see. Whenever the user leaves a slide, the answer that is selected is then pushed up onto the database. And this ensures that there is a high level of data integrity because the data saved is what the user has last seen. That was the survey. Next, Logan will take you through the PDF.
Upon completion of the questionnaire, the user is presented with a PDF document containing their compiled answers. Each question and answer pair has an alternative wording that is used in the generated report in order for the report to be worded in a way to be read and understood from the perspective of the healthcare provider. The report also dynamically substitutes in the user's preferred pronouns. While this may seem like a trivial task, we encounter multiple grammatical nuances with the string interpolation. With the correct pronouns in the report, it is more personal to the individual. The responses from the survey are also grouped differently than we saw in the app, so to be more easily parsed by the healthcare provider as well as being more topically relevant. Once the user is satisfied with their responses, they have the option to share the document using the device's native sharing or to print as well. This would then, of course, conclude the flow of use of the app for the end user once the PDF has been exported. Now we'll talk about potential future features.
Two features discussed in the initial stages of design was to allow the user to choose their own color scheme and to integrate with various healthcare systems. For the color scheme, some colors may be overwhelming or jarring to the user. The need to allow the user to pick their own color scheme was a feature we would have liked to complete if time allowed. A significant population of people with autism perceive color more intensely than others, which can be unpleasant. Adding the ability to create a custom color scheme would have allowed the user to choose the background text and accent colors that would allow them to navigate through the app with ease. Along with the color scheme, there was discussion about the future of this app and how the sponsor and researchers would like to one day have the app integrated with the user's healthcare system. The scope of this project unfortunately did not include this as a feature, so we did not take steps to implement it. Ideally, integrating with the user's healthcare system would allow the user healthcare provider to have better access to the user's information and healthcare needs. And now we're going to go into how we built the app. For our tech stack, we chose to go with Flutter for the front end. We went with the Django web framework, GraphQL, and MySQL to handle the database, queries, and data manipulation on the back end. In the initial stages of the project, each of us researched a front-end technology. We settled on using Flutter, which uses Dart as its programming language. We found that Flutter was a good choice since it has great documentation available, as well as being an easy technology to learn for cross-platform development. Flutter is an application framework that is used to natively compile applications for mobile, web, and desktop from a single code base. For our server-side tech stack, using the Django framework, which uses Python as its programming language, and GraphQL, we were able to build the back end. Essentially, GraphQL is the query language, and Django is the hosted server running a GraphQL engine. GraphQL allows the front end to make an HTTP request to a single endpoint, rather than many endpoints that you might have in a typical REST API. It allows us to create queries which are read and mutations which are update, delete, and inserts with ease. Django receives the HTTP GET or POST request, and using framework we either write to the database or return a query set requested from the HTTP request. Using GraphQL allowed us to simplify the backend's API logic, as well as implement secure authentication for the user and data. With that said, Nathan will go over the development process.
During the first term, our team primarily focused on generating user stories and assigning story points to help us better understand how long this project would take and what we could accomplish. We also spent some time getting familiar with the technologies that we chose to use for our project. While developing our application in the second term, the team would meet Monday, Wednesdays, and Fridays for stand-ups to go over work in progress and any blockers the team was facing. During these stand-ups, we used GitHub's Kanban board to organize issues into to-do, in progress, and complete columns. While there was no specified time for the team to meet and program due to work or school conflicts, the team would regularly join late-night calls and program together for a couple hours, using this group setting to work through tough issues and bugs they were facing. At the beginning of each sprint, issues were brought onto the Kanban board for our team to work on. No one developer was assigned a specific role for this project. Instead, developers would grab issues they found interesting and wanted to work on. At times, there would be multiple people working on a single issue to try and work on it from different angles. Although there were no specific roles, a list can be seen on the right in which developers contributed to which features the most.
The team encountered many unexpected events throughout the development process. The three most significant were the team's inexperience with estimating developer hours, the mandatory rebuild of the backend database, and finally, critical system testing bugs when authenticating application users with the OIT-hosted backend. Initial experiences uncovered a steep learning curve for familiarizing with Flutter and Dart and dealing with requirements changes. Consequently, many user stories were underestimated for developer hours to complete. For example, 4 developer hours were estimated for implementing pronoun selection, but ultimately required 80+ hours and additional user stories to complete. Dynamic tooltip generation was estimated at 10 hours, but required close to 30. A valuable lesson from these experiences is the complex and interconnected nature of modern code bases. We would advise future teams to pad their time estimates accordingly. Midway through development, the backend team had to completely rebuild the backend database. The early database version was inflexible with complex data and was reliant on hard coding practices and HTML artifacts. This inflexibility made the database impossible to integrate into our architecture and had to be completely rebuilt from scratch. Towards the end of development, the launch of the OIT-hosted backend unveiled a critical system-level permissions bug where the server would reject all inputs from the application layer, even queries with verified JWT tokens. Although this obstacle prevented us from deploying to the Google Play Store, the team has successfully produced a proof of concept that satisfies core sponsor requirements.
Working with Dora and Aspire on this project has been a really enjoyable experience. The team and I have learned so much about what it means to work on a project with other developers and how to best communicate with one another. I'm really excited that we were able to help Aspire migrate their AHAT tool into this new framework. Thank you, Aspire and Dora. Thank you, Bruce and Portland State University. And thank you to those who are watching.